Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Muhammad Nur Muaimin bin Muhammad Rasif, and today I will do a mini project presentation on optimum design of an off-grid hybrid PV wind power system for remote mobile base station. In this mini project, we will design an optimum solution to utilize a hybrid of photovoltaic PV and wind power system with a backup battery bank to provide feasibility and reliable electric power for a specific remote mobile base station. Our designated location is located in Kapit District, Sarawak. In this mini project, we will use hybrid optimization model for electric renewable HOMER software to do our simulation. This is the HOMER software pro that we will use. First, we need to set up our location, where in these cases, we are located in Sarawak, which in this map, we can see that it is a rural area. During this simulation, we obtain the data resources from the worldweatheronline.com, where we find the data of solar GHI, wind resources, and the temperature. First is solar GHI resource, where GHI is mean global horizontal irradiance, which is meaning the total amount of shockwave radiation received from above by a surface horizontal to the ground. Based on this graph, we can see that the highest daily radiation is on the month of September, and the lowest is on January. Next resources is the wind resources, where we find the data of the average wind speed. In this graph, we can see that the highest wind speed to occur is on the month of March, which is 0.834 meter per second. The third resources that we need the third data is the temperature resources, where we find the daily temperature for each month. We can see that based on this graph that the highest temperature is on the month of May, which is at 30.57 degrees Celsius. Next, we will decide the component that we will use in our design. At the AC part, we put the generate 25 kilowatt gunset generator, which is the original power source that located in our designated location. This generator has a capacity of 25 kilowatt, which fueled by diesel. The initial capital generator cost is to is $12,500, same as the replacement, where we need to replace with the new one if the older one broke. In our simulation, we will use the wind turbine of Xzeres Skystream 3.7 that has the capacity of 2.1 kilowatt, where at the maximum it has the capacity of 2.4 kilowatt. This wind turbine is designed for home and small business. Thus, in our problem, we need to do a system with a backup. We need to do a system to provide feasibility and reliability electric power, we need to operate a mobile base station. This wind turbine has the capital cost of $5,000. Next is our PV component, where we use the PV of photovoltaic of Aleo solar flat plate panel type, has the rated capacity of 0.3 kilowatt. The capital cost for this photovoltaic component is $4,000, and the replacement is by replace with the new one, which is $4,000. Next component is the generic 1000 watt per hour lithium ion battery, which we use to act as our backup battery storage or backup battery bank. This battery has a nominal capacity of 1.02 kilowatt per hour, where we need at least 5 of this lithium ion, where our capital cost is $3,500. Next, for our electric load. This is the electric load that we obtain the data. This is the yearly load data that shows the weekend use, the weekday use, and the weekend, which we record for the whole year on every day. In this electric load result, we simulate a daily profile, the seasonal profile, and the yearly profile. In the daily profile, we can see that the highest is at 1.3 kilowatt. On seasonal profile, the highest is up to 2.1 kilowatt. Yearly is this. For this design, we operate using this type of converter, where we use the ABB Uno 4.6 TL plus US SERA at 240 volt. Once we finish our schematic diagram on building the design, we select calculate. Okay, this is the result that we obtain after we select calculate, where this shows that where this result shows the graph of cumulative nominal cash flow over the year. The blue line is the lowest cost system and the gray line is the base case. In the lowest cost system, our initial capital is $34,000. The operating cost is $569 and the cost of energy is only up to $0.79. The base case for our design is the initial capital is $12,000, the operating cost is $35, and the cost of energy is $8.9. In our simulation detail, in cost summary, we can see that the lithium ion has the highest cost type than the LEO solar PV panel. In terms of electricity, in terms of the electrical, this is this bar graph shows a monthly electric production using the PV panel, where the production is up to 7,165 kilowatt per hour per year, where the consumption of AC primary load is at 4,107 kilowatt hour per year. In terms of compare economics, we can see that it presents a reservoir of $431,539. The annual worth is $33,381 per year. The return on investment is 153.7%. The internal rate of return, or the IRR, is at 145.4%. The simple payback is 0.78 per year. The discounted payback is 0.82 year. This is the time series detail analysis, where we obtain after we run our simulation. This is in terms of hour, this is in terms of month. In terms of the month, this graph shows a global solar monthly average over month, where the highest is on the month of November, where has the annual maximum is 1.3